Okay, hi student. Okay, so kita dah habis cuti. Kita akan sambung balik topik untuk minggu lepas. So, jom belajar.
Okay guys, let's continue our lesson today to 3.1.4 justify the importance of knowing the value of gravitational acceleration of the planet in solar system. The gravitational force is a universal force. The formula G equal to gm over r square can be used to calculate gravitational acceleration on the surface of other bodies such as planets, the moon and the sun. So, let's compare the gravitational acceleration for the moon, the sun and the planet in the solar system. But teacher will choose the several planet that I will give the answer, and others I want you to complete this table by yourself. Okay, so use the formula for the Earth. You will get the gravitational acceleration is 9.81. Okay, so for the sun we have 274. And for the moon, we have 1.6 for the gravitational acceleration. And next, I will choose for Jupiter. Okay, for the Jupiter, we have 24.8. Okay, so the rest, I want you to complete this table. By using the information for the mass and the radius, you need to find the gravitational acceleration for each planet. Okay? Okay, why? Okay, next we learn for 3.1.5, describe the centripetal force in the motion of satellite and the planet system. Centripetal force is F equal to mv squared over r. So, what is centripetal force? Centripetal force is the force that acts to an object in circular motion. The circular motion mean here, we have three positions of the satellite which orbit around the Earth at uniform speed. Okay, so we can observe the direction and the velocity of satellite at each position. Okay, so a body move in circular motion always experience change in direction of motion, even though the speed is constant. Okay, maknanya jika satelit ni bergerak mengelilingi Earth, maknanya direction dia akan berubah, sekejap dekat sini, sekejap dekat sini, sekejap dekat sini. Correct? Even though the speed is constant. So therefore, the velocity of the body will change. A force is required to change the direction of motion of body. The force that act of body with move in circular motion is called centripetal force. Okay, so bila satelit ni berpusing mengelilingi bumi, ada orbit dia, dia akan ada force untuk merubahkan direction. So macam akan ada force untuk satelit ni bergerak. So, force tu yang menyebabkan dia bergerak sekeliling bumi dipanggil centripetal force. Okay, student? Okay. So, for the force ni, we have the formula which is F equal to mv squared over r. So, for the S is centripetal force, m is a mass, v is linear speed of the satellite, and r is radius of the circle. Okay? So, the factor that affect the centripetal force, we have three factors. First one, we have mass of object. Next, we have linear speed. And third, we have radius circle. Okay, for the mass, the relationship is if mass increase, the force will increase. The centripetal force will increase. But for the linear speed, when the velocity or the speed is increased, the force is also increased. But when the radius of circle is increased, the force will be decreased. Okay, this is the relationship for the factor that affect the centripetal force. This is the diagram that you can see that we have a three movement satellite here. So it started from here and it moved to here and here. So surrounding the Earth, and we have a velocity here, and this is the radius of the circle, and the velocity is the linear speed, and the mass is the mass of the satellite. Okay? Okay, student. So if the centripetal force have a velocity, that means we'll also have acceleration. So here is centripetal acceleration, we call AC. Is the acceleration that directed toward the center of the circle. So we compare the formula for the force and the formula centripetal, and we get A equal to V squared over R. So V is a linear speed of satellite and R is the radius of the orbit of a satellite. And R here, we talk about a satellite and Earth. So R will be equal to h, will be the height of the satellite to the center of Earth, and we have R, the radius of Earth. Okay, so let's answer the example. A hammer throws athlete swinging on the iron in a horizontal circle before releasing it. What is the centripetal force that acts on the iron ball when the iron ball is moving at the speed of 20 meters per second? So let's list the information that we have. First, we have a mass. First, we have a mass here. For the iron ball that is being given, we have 7.2 kilogram, and we have a radius which is 1.8 meter, and the question also gives a velocity which is 20, and they ask us to find the centripetal force that act on the iron ball. Okay, so the first formula we have to use is F equal to. Okay, next let's answer the example. A hammer throws athlete swinging on an iron in a horizontal circle before releasing it. What is the centripetal force that acts on the iron ball when the iron ball is moving at the speed of 20 meters per second? And the question given mass equal to 7.2 kilogram and the radius is 1.8 meters, and for the speed we have 20 meters per second. Okay, first we have to write the formula that we have to be used for the centripetal force, which is F equal to mv squared over r. Okay, so let's put all information in the formula. We have mass, which is 7.2, and we have v, which is 20 meter per second, and we have a radius, which is 1.8. So let's calculate the answer, and the answer is 1600 Newton. Okay, so remember the centripetal force must be in Newton because it's a force. Okay, next let's answer the example 2. With a satellite orbiting the Earth at a height which is 480 kilometer, what is the centripetal acceleration of the satellite? So it's given linear speed of satellite which is 7.62 multiple to the 10 to the power of 3 meter per second, and we have the radius of the Earth which is 6.37 multiple to the 10 to the power of 6. Okay, so we have to use the formula of the acceleration, centripetal acceleration. So we have AC v squared over r. But before that, we have to know that the height is given in kilometer. So we have to change that height to the SI unit. So 480 km must be changed to meter, and we get 480,000 meter. Okay, so remember to So remember to be careful with the SI unit because it will change your answer. Okay, so everything is correct SI unit right now. So let's put everything in the formula. So we have for V here, the linear speed, we have 7.62 multiple 10 to the power of 3. And remember to put square here. And we have a radius that we already find, which is here. So the radius for this is height plus radius of the earth. So we have 4,680,000 plus to the 6.37 multiple to the 10 power of 6. Okay, so the answer will be 8.48 meter per second to the power of 2. Okay, so that is for example. Okay, let's move to the next topic. Next, we move to the next topic, which is 3.1.6. Determine the mass of the Earth and the Sun using Newton's universal law of gravitation and centripetal force. So, first, we have to derive the formula to get the formula for the mass of Earth. Okay? So, distance traveled by the Moon when making one complete orbit around the Earth is 2 pi r. So, we have here linear speed of the Moon is 2 pi I over t. So, t is the full, it's a period of revolution of the Moon around the Earth. Okay? So, let's determine the formula of mass of Earth. So, we derive from the two formula, which is Newton's universal law of gravitation and centripetal force formula. Okay, from these two formula, we derive that we equate two equation. We have G and mass 1, mass 2 over R square equal to mv square over R. And we cancel the common factor, which is mass, and we have Gm equal to Rv square. So we must cancel this m and this m. And we substitute the v, which is the speed of the Moon, 2 pi r over t, to this v. And we get here, and we arrange for G to move G to the next equation to get the mass of the Earth. And the last equation, we have mass equal to 4 pi r square, r to the power of 3, and over t to the power of 2. Okay, so t, remember the period of revolution. Okay, to make you more understand about the topic for the mass, the Earth and the Sun, let's do the example. A diagram shows the Earth, planet Mercury, and Venus revolving around the Earth, around the Sun. So, mass for the Sun is 1.99 multiple to the 10 to the power of 30. And he's given the gravity of constant here 6.67 multiple to the 10 to the power of negative 11. So, we can refer to this diagram, which is the first orbit for revolving around the Sun is Mercury. The second orbit will be Venus, and the third orbit will be the Earth. So the first radius for Mercury is 5.79 multiple to the 10 to the power of 10. And the radius for the Earth, which is in the third orbit, we have 1.5 multiple to the 10 to the power of 11. But for the Venus, which is the second orbit, that's not given the radius. Okay, so the question is, find the period of revolution of Mercury. So if we want to find the T of the Mercury, so first we have to write the formula. Okay, the formula will be mass equal to the 4 to pi square r to the power of 3, and we have over g t square. Okay, for this, let's put all the information that have been given. Okay, so we have 4 pi square And for this radius, we have is given here. So 5.79 to the power of 10. Remember to put the power of 3 here. And G is the constant, which is 6.67 to the power of 10 negative 11. And for the T, we have to find for the T. So for the mass, we have to use the mass of the sun, which is 1.99 to the power of 30. Okay, so after we calculate here, the T will be 7.96 multiple to the 10 the power of 6 second. So remember, this is second. So we can convert this second into the years, and we have 0.24 years. So 0.24 years is the period of revolution of Mercury to complete the one circle around the sun. Okay, let's answer the second question, which is the radius of the orbit of Venus. So you want to find the radius of the Venus. So it's given the period for the Venus is 0.61 of year. Is given in the year. So we have to change the year to the second. Okay. So T, we have year 0.61 year. When have to change to second, so we have 1.93 to the power of 7 second. Okay, so we already changed here. So let's put in the formula, which is mass 4 pi square r, and we have g t square. Okay, let's move it a little bit. Okay, so for the mass, we have used the mass of the sun, which is 1.99 to the power of 10 multiple of 10 to the power of 30, and we have 5 pi square here, and the radius is, we need to find the radius. And for the G, we have 6.67 multiple to the 10 to the power of negative 11, and we have a T that is changed to the second, 1.93 to the power of 7. Okay, so we calculate here, and the radius we'll get is, the radius that we will get is 1.08 multiple to the 10 to the power of 11 meter. Okay, so this is the last subtopic for this 3.1 chapter. If anything you don't understand, please contact me, and please redo the table that have been given. Okay, so that's it. Bye bye.